This is the gas laws and properties video 2 in the review presentation. All right, so we left off talking about Charles' law. And as I said before, that Charles' law relates volume to temperature. And so for Charles' law, we assume that the pressure is staying constant. And so what Charles' law ultimately tells us is that as the temperature increases, the volume decreases. Or as the temperature decreases, so the temperature drops, then the volume is going to drop. Right? And so you would also see this situation in your car tires, right? The temperature of the gas inside your car tires goes down, or the temperature goes down, and so the volume's going to drop. Right? You're going to see that volume of your gas of your tire get much smaller or lower. All right, the last one is Gay-Lussac's law. And Gay-Lussac's law relates pressure and temperature. And so for Lussac's law, what we assume is that volume is kept constant. So the way that you could write that formula is that initial pressure P1 divided by initial temperature T1 is equal to pressure, the final pressure over divided by the final temperature. So that means that if I start out at a certain pressure and temperature, and then I increase my temperature, then my pressure, my P2 will go up as a result. And we will actually be able to do some calculations later on in this unit so that you guys can actually prove this and see how it works. So lastly is the combined gas law, and the combined gas law puts all of the variables together. So for this one, we're not assuming that any of the variables are actually kept constant, and therefore we have to use all three. We have to use pressure, volume, and temperature. So what the combined gas law tells us is that pressure P1 times V1 divided by T1 equals P2 times V2 divided by T2. All right, so it takes all other gas laws into account. And that's it.